Hi everyone. Yes, my name is Beth Skurrie. I'm a co-founder at Pactflow, a SaaS product that we've built to help make distributed testing easier. Now, today I'm going to talk to you about how you can test smarter instead of harder when it comes to your distributed computing environments. In 2013, I was consulting out at a company that had a big problem. Now, the name of this company will be familiar to you all. It's realestate.com.au, or REA. And the problem they had was quite common to organizations of their size that had grown as quickly as they had. Now, they had their fair share of what we now call monolithic software, but back then was just called software. Now, there's nothing inherently bad with monolithic software, but these monoliths were the bad kind, the kind that were tied and coupled in really scary ways to every critical system in the company via black holes and wormholes and mysterious paths. And so when it came to adding features and making changes, everybody was quite rightly nervous about making deployments. So the way that we would deal with this was to basically throw all the changes into this single test environment and then test the living daylights out of it, and then release everything together in one big bang deployment. And this was really stressful, and the rate of change was slow, and this was the problem. It was a really long time to get features out to market. So they decided that this had to change. So they decided to try this newfangled thing called microservices. Microservices can be really good because they help take your code and break it into small, manageable chunks that can be deployed independently, understood more easily, removed, and this works pretty well for them. They took a bit of new functionality, and instead of just shoehorning it into an existing monolith, like had been the case previously, they built a couple of new microservices, and it was quite easy to test and deploy these, and because that went so well, they added a few more, and because that went well, they added a few more, and a few more, and a few more. And then they discovered they had a new problem. They'd solved a problem by using microservices, but that had actually introduced a new problem. And this is going to be a bit of a common theme in my talk. We solve problems, and that leads us to discover new problems. Now, the new problem was the testing. Now, it turns out when you take, when you decouple all your business code into nice little bite-sized microservices, then you take an end-to-end suite and put that over to test all your microservices, you're actually recoupling your code at the test layer. You're undoing all that good decoupling work that you did in your business code and recoupling it in your test code. So what this team at REA discovered was that making changes was becoming slower again. One service would block the other service from being deployed, and it was undoing one of the goals of microservices, which is to allow you to deploy services independently. So this led them to really question the value they were getting out of their testing. Should they do these tests or should they not? If they didn't do them, they risked letting integration bugs into production. And I mean, that's the point of testing, is that we want to find our bugs before they go into production, not after. So what were they to do? All right, before I go into this solution, I'm just going to do a little bit of a detour story. So a few months before I started consulting out at REA, I saw this really interesting talk by a guy called J.B. Rainsberger. You've probably heard of him. Now, this talk was discussing how to test integration points, and the title of it was Integration Tests Are a Scam. And he discussed an alternative approach to our traditional integration testing techniques that works like this. Imagine we had a consumer and a provider. Now, it doesn't really matter what the consumer and provider are. This theory works whether we're talking about classes or modules or services. It's all the same. Now, we write a test for the consumer to make sure that the consumer sends the right request to the provider. And we use a mock provider instead of the real provider. And we check that the right request is sent and that we can correctly handle the response that we get back. Now, this is nothing novel or exciting. This is what we do all the time. But if you have a look at this diagram, you'll see that half of it is missing. What we're missing is the part where we send the same request to the provider to make sure the provider actually does handle that request, and looking at the response that comes back to make sure that it actually does send the response that we think it will. If we have these two matching sets of tests, we've achieved test symmetry. We've effectively made sure that our mock provider behaves the same way as our real provider does. And this means that when these two components meet each other in real life, they're most likely going to work together correctly. Now, I found this concept of this test symmetry really interesting in this talk that JB was giving, but I found myself a little bit disappointed at the end of the talk because he didn't have any suggestions for any tools that would help us achieve this test symmetry. So finding this talk so interesting, I gave a brown bag on it to my consulting company, and at the end of it I said, hey, has anybody here heard of any tools that would help us achieve this test symmetry? And my workmate, Ron Holzhausen, who was consulting out at REA at that time, said, well, actually, we've just built a tool that does something really similar to that. And it's for HTTP microservices. And this is how it worked. Sorry, let me tell you about test symmetry. First we get, the reason this test symmetry solves problems is that we get this fast feedback on both sides. We have these few dependencies. When you're running contract tests, you don't need to have the world running. You just have the bit that you're interested in. You don't need a dedicated test environment to run these tests in. You can just run them in your normal CI on your local test environment and use the same debugging tools that you would to do your normal coding. Would you rather debug an issue on your local machine, or would you rather debug an issue on a test environment? These tests are much more reliable because you're not dealing with all the networking issues and the deployment issues that complicate things. But we have introduced a new problem. It's now hard to keep those two sets of tests in sync. Now let me come back to this tool that my workmate Ron was talking about. Now it was called Pact, and they had developed this tool in-house to help solve the problems that they were having with their distributed testing environments, and this is how it worked. This diagram is going to look quite familiar to you, sorry. We have a consumer and we make a request to our mock provider. And this is the bit where that pattern differs from what I was just discussing before. While we're running those tests, we write the request and the expected response to a contract file. Then we take that contract file over to the provider and we replay the request and we look at the response that comes back, and we make sure the response that comes back matches the expected response. And if it does, we've verified that our mock provider behaves the same way as our real provider. Now, the thing that helps us here is we now have something to keep these two sets of tests in sync. Our test symmetry solved the problem of separating integration test, and this contract solves the problem of keeping those two sets in sync. Now, not all services are HTTP services. A lot of services these days are message-based services, and With message services, we actually have the same problem. It's really easy for these two sides to get out of sync. And in fact, if something is unexpected or mismatched between the consumer and provider, sometimes it's even harder to find this issue, because when something goes wrong with an HTTP request, you often get an immediate failure. But with a message service, the message might just get dropped in a queue somewhere. You don't always get that immediate failure. So having a contract between a consumer and provider is almost more important. Now, you can do exactly the same thing with a message contract. You can write a test that shows that a consumer handles an expected message a certain way, and then you can write that message to a contract, and then you can run a test on the other side to make sure that the provider actually does produce the message that you think it does. So contract testing solves the problem of keeping these two sides of our tests in sync. And instead of introducing a whole heap of new problems, it actually brings a lot of benefits. Now, before I talk about those benefits, I just want to do a little bit of a crowd survey here. Imagine you've written a piece of new code. How long is it before you find out whether there's an integration bug in it? Put your hand up if you would say it's less than 15 minutes. Put your hand up if you'd say more than half an hour. Yeah, more than a few hours. More than a few weeks. Keep your hand up if you work at a bank. Hashtag not all banks. I did ask this question of one of my workmates once, and he was like, 6 weeks? He was out at a bank. Anyway, wouldn't it be much better to find these bugs before we even got to the deployment stage, before we got to the integration test phase, before we'd even pushed our code? Contract tests help you find the bug early in your development cycle. So you're reducing the number of integration bugs that you're even committing into your code base. Now, contracts help you make changes with speed and confidence, because you get this really fast feedback and you can see what the impact of any change to an API will be really fast. Contract tests allow you to deploy independently, because once your side of the contract is working, or both sides of the contract is working, each of you can deploy at your own schedule. So the deployment schedule of your service is not slowed down by the slow deployment cycle of another service. Now, if you're using this type of contract testing, which is actually called consumer-driven contracts, you're actually getting an even better design for your API. Now, most APIs are designed like this. I have a data source. What's the fastest way I can get the data out of my data source into an HTTP response? But that doesn't make for a really usable API, because that's not thinking about how the consumer is actually going to use this data. So consumer-driven contracts actually turns that process around and starts by thinking, well, as the consumer, what way of formatting and accessing this data makes sense for me? So you end up with an API that's actually optimized for real-world usage, because it's being driven by your real-world examples. Now, I've told you a bit about what contract tests can do for you, but let me tell you a bit about what they don't do. Now, contract tests are not functional tests. One of the traps that developers often fall into when they start this type of testing is they try and use the contract test to make sure that the provider is being implemented correctly. That's not the job of the contract test. The contract test is there to make sure that the consumer and the provider have a shared understanding of the messages that are going to flow between the system. So here's a quick example of the difference between a contract test and a functional test. Imagine I have an API where I am sending a post to a collection to add a new object. A contract test says, hey, when I send you this payload, I expect this kind of response and this payload back. It doesn't say, hey, did you actually add this item to your data store? The functional test says, hey, when this payload comes in, do I actually add this object to my data store? That's not actually the concern of the consumer. The consumer is concerned with what the requests and the responses look like. It's the job of the provider tests to make sure it does the right thing with what you're sending it. Now, contract tests are not an API specification. So an API specification describes what a service will do for everybody, whereas a contract is a specific thing between one consumer and one provider. And this is what helps you make those changes quickly, because you know exactly what each consumer expects from each provider and whether the bit of code you're wanting to change is actually used by anyone. Now, it takes two to tango when you're writing a contract test. It takes one side to record that contract and the other side to replay and verify it. So contract test, or this kind of contract test anyway, doesn't really scale for public services and services when there's just lots and lots of consumers. Imagine if GitHub was trying to verify contracts with all of its millions of users. It just doesn't work. That's when the traditional versioning approaches of never change an API, just make a new version, are a better technique. Consumer-driven contracts have this sweet spot for internal APIs where the number of consumers and provider teams are actually kind of small enough that you can maintain some kind of personal relationship with each other. Now, contract tests are not a silver bullet. They're not going to magically make every single integration testing problem you have go away. But I'm really confident that they will reduce them, and this is why. Now, you're probably aware of the testing pyramid. And it's an overly simplistic view of testing, but the main point that it expresses is really true, and this is that the more code that your test covers, the fewer tests you should have of that type. So end-to-end tests are really good for making sure that the business value of your code is being delivered and that everything is working together correctly. But they're really bad at showing you where something has gone wrong when it goes wrong. Isolated tests are really good at showing you where something has gone wrong, but they don't give you that confidence that everything is going to work together. Now, all of these types of tests have a role to play, and the key is to get them in the right balance and using the right test for the right tool for the right job. Now, problems arise when we try and use end-to-end tests for things that isolated or smaller scoped integration tests would do better. When we try and use end-to-end tests to make sure that every field in our request and our response is correct, we end up in the testing pyramid of hell. That is testing harder, not smarter. Contract tests live on this boundary between integrated tests and isolated tests, and they allow you to reduce the number of end-to-end tests that you need because you're not using these high-level tests to check really low-level concerns. That's already been done. This means you can really speed up your release cycle. Now, this is not going to work for everybody, but at the team that I ended up joining at REA when I actually joined them, they actually threw away all their end-to-end tests and just relied on these contract tests. And instead of spending that time and effort on maintaining those end-to-end tests, they spent time and effort on doing the things that would help them find and fix bugs quickly. So these were obviously the contract testing, getting really good aggregated logging, really good metrics, semantic logging, alerting, correlation IDs to help them see the flows of data through their systems. And this meant that the turnaround time when issues were discovered was really short. They could find a bug and fix it in less than an hour. So that meant that each deployment was much lower risk because they knew that if everything went wrong, it was really quick to recover from. Now, I'd like to tell you a bit more about my experiences on that team. because that's what got me started in this whole contract testing journey. Now, when I started at REA, Pact was just this little library that was running on this one team, written in Ruby for Ruby microservices. And now it's grown to be an open source project for multiple language, covering multiple protocols. I'd like to tell you a bit more about how that library went from being this little Ruby project to being this rather large open source project, and tell you about the problems that we encountered and how we fixed those problems, because I might have told you a little white lie before when I said that contract testing doesn't introduce new problems. It actually does, but they're more interesting problems to solve than integration testing. All right, so let me just do a quick recap of how this works. The consumer runs tests that check that the consumer code is making the right calls by using a mock provider, and we record that conversation, and then we replay it on the provider side, and we make sure that the responses that we get back match the expected responses. And if they do, we know that the real provider behaves the same way as the mock provider. Now, one of the things you might be thinking is, okay, you've got this contract that's been generated by the consumer tests. How do we get that contract from the consumer side to the provider side? Now, we tried a few different techniques to solve this problem. We tried using copy-paste, and that worked about as well as you'd expect. We tried using Jenkins build artifacts, and that kind of worked well until the number of builds that we had in Jenkins exceeded the maximum limit, and then they started getting deleted and problems. So given that this problem had been introduced by having too many microservices, the obvious solution was to add another microservice. So on one of the DS Hack days, we threw together this thing that we then called the Pact broker. And the Pact broker is this middleman that sits between the consumer build and the provider build, and it allows you to exchange the contract. So the consumer build will run and publish the contract, and then the provider build will run and pull down the latest version of that contract. So this meant the provider was always working on the latest version. Now, one of the things we discovered when we had been using this contract testing over the period of a few months was that you can make the same request, and depending on the state of the provider, you can get a different response. So the way the contract had initially been written was that when the provider receives a certain request, it will return a certain response. Now, if you only get one chance at this, you don't actually get to exercise all the code paths in your code, because sometimes you might request for a resource and maybe it doesn't exist, so you get a 404. And sometimes you request the same resource and it does exist, so you get a 200 and you get the actual resource. So this is the way a contract might look. When a provider receives a request for /alligator/Mary, then it will return a 200 response with this JSON body. We might actually get different responses for that request. So what we needed to add was a way to set up the data, a way to tell the test what we expected was going to be on that provider, so that when we ran the test, we got back the response that we expected. This is what we call provider states. So now we can say, given that there is an alligator Mary, when I run this request for an alligator Mary, I get back the alligator that I expect. So with contract testing, you still do need to think about your data, but the setup for each test is much less. You're not having to set up the entire world. You're just setting up the data for this particular request. Now, as time went on and we were adding more and more data into these contracts, they would start to fail more often. So we'd add a new field and we might say, I expect this address with this street. And then the test would fail because the street name was a mismatch. And this actually got really, really annoying until one day I just added this, what I thought was going to be a temporary hack, because I was like, actually, I don't care about what the value of this street is. I just care that it's a string. So I put in this little hack that made the matching, instead of do exact matching, do type-based matching. And that actually worked so well that led us to realize that in a contract test, you actually don't really care about the exact values. You really just care about the shape of the document and the types of data in that document. So what we added into the Pact library was this ability to specify the consumer's requirements for a piece of data. So maybe you'd say, this is a number, this is a string, I need it to match this regular expression. And that made the tests much more flexible and meant that when we were getting failures, they were much more meaningful failures. They weren't failures just because a particular string was capitalized the wrong way. And this means that your test data setup is much less critical to get everything exactly right. Make it much easier. Now, in our contract testing journey, we've automated our contract testing exchange. We've set up our test data. We've made our contracts flexible. It must be time for a new problem. Now, when these projects were at the start of their life cycle, the builds kept running daily, and most of these teams are kind of working on both sides of the integration. So the builds just got kicked off all the time. But one day it happened that a change was introduced to a contract, and the provider build didn't get kicked off immediately. And a few days later, it got kicked off for some unrelated reason, and the contract suddenly changed. The contract test suddenly failed, and we're like, but why has this failed? We didn't change anything in the provider. And that led us to a couple of realizations. The first is that when the contract does change, the other service needs to know about it. But secondly, that contracts are not a good substitute for really good communication between the teams. Now, the first problem was pretty easy to solve. We added in this concept of webhooks to the Pact broker so that when the contract changed, you could kick off a downstream build. When it comes to the problem of the contracts not being a good solution for communication, we did nothing. Because it turns out that contracts are still not a good substitute for good communication between teams. Just because the contract gets generated on the consumer side doesn't mean that the consumer team gets to dictate everything that the provider team does. And it doesn't mean that the contract can't be wrong. It's not dictator-driven contracts. The contract is a starting point for a discussion about how this API could work. It's not something that you should be using to hit each other over the head. You've still got to keep talking and keep collaborating. All right, that's my little rant over. Okay, so the provider knows when our contract has changed, and we're still talking about our API design. Time for a new problem. All right. When the contract gets generated, it lives on the consumer side, on the consumer CI. When the contract gets verified, that tends to happen in the provider build. So the provider team is very aware when that contract has failed. But the consumer team aren't necessarily, because the consumer team doesn't always have visibility of the provider team's build. Now, this is a problem that we can solve with technology. What we added into the Pact broker was the ability to publish those verification results back to the provider. And then the ability for the consumer to query those verification results to see whether or not their contract had passed. So the consumer CI publishes their contract, the provider CI publishes the verification results. Now we have this full circle of communication. This is a flow that could work for you. Every organization's CI is different, but here's a pretty standard one. The consumer CI runs their tests. They generate the contract and publish the contract. The Pact broker kicks off a webhook to run the provider CI. Provider CI fetches that contract, verifies it, and then publishes the results back to the consumer. Now, the consumer CI can then do what it needs to do with those results, perhaps deploy the latest version to a test environment or even a production environment if that's the way you like to do things. Now, something we discovered was that you can actually skip this second part most of the time because it's not actually that often that the contract changes. Like the number of commits that you'll make to a consumer that actually don't involve changing the contract is actually going to be more often than when you do change the contract. So when you publish a contract that is exactly the same as a previous contract, you're in a sense pre-verified. So you can actually go ahead and deploy your consumer straight away without waiting for that verification step to take place. Now you might be looking at this thinking, oh, that looks really complicated. And I'll be honest with you, it actually takes some thought to get this all set up and integrated into your CI. But once you've done that initial effort, the effort to add new integrations is the smallest amount of effort. You're just adding a few lines to a consumer test. Whereas your end-to-end tests might start off conceptually quite easy. But as you add more and more integrations into that test suite, the amount of effort to maintain and execute those tests gets bigger and bigger. Now, the reason for that is that when you running an end-to-end test suite and you add a new interaction and you add a test for that interaction, it's unlikely that you're going to be able to go straight to that bit of code that you want to test. Usually you have to set up some data and then execute this step and go to this resource and go to this page and click this and then get to the bit that you're interested in. So you're going through code over here that you've probably gone through tens or hundreds of times in that same test suite. So for your new test, there's more overhead than there is actual interesting test. And this overhead is the reason that end-to-end test suites bloat so quickly. A contract test allows you to test just the bit of code you're really interested in. Do you want to test harder or do you want to test smarter? Now, you probably heard the saying, if you can't deploy your services independently, you don't have a microservices, you have a distributed monolith. Do not build a distributed monolith. Now, one of the things we discovered when we were publishing contracts from every consumer build and verifications from every provider build was that we were able to build up this matrix that showed us which versions of our application were compatible and not compatible with each other. And this is a tool that actually allows you to do your deployments independently. On top of writing your code in a way that's always backwards compatible, and this can show you which builds are going to work with each other. So we know that if we have version 54 of a certain provider in production, we can look at this matrix and say, well, actually, we know that 11 has successfully passed the test, so we can deploy that. But we should not deploy version 12. One of the other benefits you get when you're publishing all this contract data to a centralized place is you can start to build up these dependency graphs to show what services talk to what other services. And this can be really helpful for new people coming into an organization to see how the services relate to each other. This is actually a real diagram that I've obfuscated the names from when I was at REA. I believe this diagram is now so big that it crashes the page when you try and load it. So you get this emergent living architecture when you build your documentation from your actual code, and it can't get out of sync. It's always going to be accurate, unlike your Confluence documents, which you write once and read never because you can never find them again. You can also build up this really nice human-readable documentation for the interactions that can tell you how your two services relate to each other. And this is despite the fact that Pact is primarily a tool that is used by testers, by developers when they're doing their test-driven development. This can be useful for manual testers because they can see what's covered by the test cases and what cases they might be missed or might need to cover in a different way. So one of the most common questions I get when I talk about contract testing is, but what about Swagger, or Open API Specification as it's called now? So technically, Swagger is not a contract testing tool. It's a documentation tool. But it can be extended to kind of perform a similar role. You can have a mock service that's generated from your Swagger and use that in your testing. Now, this can be useful, but what it's missing out is the ability for you to know which parts of your API each consumer is using. And the ability to know which parts of your API each consumer is using is the thing that makes you be able to move quickly. When you don't know what parts are being used and who's using them, you don't want to change it. So what you end up doing is creating an entirely new version of that resource or that API, and then you have the overhead of maintaining all of those versions. When you know who's using what, you can say, oh, actually, we need to change this field. It used to be just one item. We're actually going to make an array. Let's see who's using it. Oh, it's just this team over here. Well, let's go and talk to them about changing this. And then you can start to roll out deployments so that the consumer can handle either an array or an object, and it's only one, and then the rest of these guys don't care about it. It means you can just make these changes really quickly. You don't have to worry about deploying the entire world all over again. There is a really interesting approach, however, that might allow you to get the benefits of both of these sides. Atlassian has open sourced a tool that they actually wrote internally, which allows you to verify a pact against a Swagger document. So this gives you the benefits of really fast feedback because you're not actually waiting for an entire verification process to run for your contract. You're just verifying two documents against each other. And even you get slightly less confidence because you're adding in this extra layer of abstraction, but for some organizations, the trade-offs of speed against confidence is actually a good decision. What this relies on, though, is that your Swagger document is in sync with your provider code. So you either need to make sure that your Swagger is generated from your code or is validated against a running instance of your provider. Now, this is something that we are finding quite interesting, and we'd really like to add this into the Pact Broker code to start supporting this natively because we think this might revolutionize contract testing and make it much more accessible to companies that are finding difficulties with that verification process and the waiting. So this is where we're going with Pact in the future, trying to make this workflow a bit nicer and more collaborative. So contract testing solves the problem of shipping code faster. This is kind of one of the things that I like about working in IT is that we solve problems and we discover new problems. If we solved all the problems and there were never any new problems, it would be really boring. So what are the new problems with contract testing? Come and join me and find out. If you're interested in learning more about this, hop on to pact.io. And if you'd like to have a broker of your own to play about with, hop onto Pactflow.io and you can get your own free hosted broker. Come and chat to us on Slack or Twitter or Pinterest or Tumblr. No, just Twitter. And if you have any questions, I think we probably have some time now.